All right, so question 3, this is about an Ito integral. So we have a strategy which is discrete, so it's a simple strategy. And we're interested in the integral of the strategy over Brown motion. So if you want, it's the gain of money by applying this strategy on the Bryan increment. All right, so remember what's the definition. Okay, so it's good to actually do a picture here. So this is on 0, 1. So I'm going from 1/3, 2/3, and 1. Make it a bit better. Okay. And now I have a strategy, okay, which is 1 on 0, 1/3, 2 on 1/3, 2/3, and 3 on 2/3 and 1. So 1, 2, 3. Alright? So this is actually not random, doesn't depend on the path, it's always 1, 2, 3. Now, what's the integral? So first question, what's the integral I 1/3, I 2/3, and I 1? So again, the integral is just multiplying the strategy by the Bryan increment and sum them up. So I'm going to put the blue color. I 1/3 is the Bryan increment on the interval, so B 1/3 minus B 0 times 1, the value of the strategy on the interval. I 2/3 is the first one, so I accumulate, right? Plus the second, which is strategy 2 times the Bryan increment on the second interval, and you see the gist of it. I1 is the sum, so again I get the same thing plus 3 times. So in the last interval, B1 minus B 2/3. Okay, so these are the 3 random variables now. The question is to say, so I wrote this as a sum of Bryan and increment, and argued that these 3 is a Gaussian vector. So it's clear that it's a Gaussian vector because B1, 3, B0, and B2, 3, and B1, they form a Gaussian vector. And what I have is a linear transformation of these vectors. So I 1/3, I 2/3, I 1 is a linear transformation of B0, which is 0. Let's write it anyway. B 1/3, B 2/3, and B1. Okay, so this is 0, so it's a bit redundant. Alright, so that takes care of A. Now I know that these integrals are actually just these random variables are Gaussian, so they're jointly Gaussian. Okay, now compute the mean and the covariance. So that's easy. So the mean, again, the mean of an Ito integral is always 0. And it's kind of obvious from the definition, so because if I do the mean, for example, of the last one, it's the mean of this plus the mean of this plus the mean of this, but this is just the mean of the Bryan increment, which is 0. Again, E2 integrals have mean 0. Now what about the covariance matrix? That's a little bit of calculation. Let's do I13 square. Well, I13 square is just the variance of the increment on 0, 1/3. So it's 1/3. Now what's the variance for I 2/3? Well, the variance, if I look at I 2/3, this increment is independent of this increment, so it's just the sum of these two. Okay, so it will be 1/3 plus 4 because 2 square, so let's write 2 square, times the length of the interval, which is 1/3. So it's 5/3. And then the last one, again, I have 1. All the increments are independent. So I'm going to get the sum. So it accumulates. It's the sum of each of the increment. And the last one is 9, 3 square, 1/3. And if I do the calculations, 1 plus 4 plus 9, divided by 3, it's 14/3. Alright. Okay. So that's for the variance of I1. Now what about the covariance? Again, use the fact that the increments are independent. So if I do I1/3, I2/3, if I do the covariance between the two, the covariance I'm going to have, it's going to be the covariance of this plus the covariance of that. But these are independent, so that gives me 0. So what I get is really just the variance of the first one. So this is variance of 1/3, which again is simply the variance of the first. Okay. And last one is I1/3 I1. Again, use the fact that the increments are independent. So what I'm going to get, okay, so I think 1/3 again is just, this is independent of this and that, so I get just 1/3 again. And I forgot this last one, I2/3 I1. Okay, so if you look now, so what I'm going to have, so it's I2/3 in 1, so I'm going to have this guy with itself, this guy and this guy, but that's 0 because they're independent, and this guy with itself, and then again this guy with this guy gives me 0, this guy gives me 0, so that gives me 1/3 plus 4/3, which is 5/3, and that's actually the variance of the last one. Okay, so in fact we're going to see probably Monday, whenever you have two integral, the covariance is 0, the minimum between S and T, and I sum or integrate the variance of the strategy, and it's exactly what you see here. Alright, so we're going to see that later. Okay, so that takes care of B, and now I need to compute I1 B1, but what's I1 B1, and I have to decide if they're independent or not. There are the answer, so I'm going to maybe just talk about it. So the trick here is that B1 I can also write as the increment. So B1 is really, let's go to write that. B1, or BT more generally, is really the integral from 0 to T, 1 dBT. I should use S for the time, dBS. Okay, because this is really the strategy which is 1 everywhere. So it's 1 times BT minus B0. Okay, so the strategy is 1. So the difference is just that here I multiply each increment by the strategy 1. And therefore when I look at the covariance, okay, all the increments are independent. So the only thing that you pick up, the mixed terms are 0. Covariance between the increments are 0. So what you pick up is the variance. And then the strategy for I1 is 1 on the first interval, 2 and 3 on the third interval, whereas for B it's simply 1 everywhere, so that's what you get. So if you if you compute that, you get 2, and so the covariance between the two is not 0, therefore it cannot be independent, right? If you're independent, the covariance could be 0. Alright, so that's it for question 3.